to the next part or the final part of this automation in manufacturing, which is the computer integrated manufacturing.
Okay, so when we talk about CIM or computer integrated manufacturing, we are referring to the pervasive use of computer system to basically automate the manufacturing system in the industry, and also to computerize the manufacturing support system. So the automation itself is aimed at reducing the amount of work that being done by a manual worker. So if we remember that we talk about in the very beginning of the lecture, it's that the potential computerization is done in both facilities itself as well as the manufacturing support system. So automation in facilities, we know straight away that we are trying to automate the process and we are trying to improve the product. And we also talk about the 10 strategies for process improvement and so on. This is what are the potential automation applications inside the facilities. And automation in manufacturing support system, however, is aimed at reducing the amount of manual and clerical effort in product design, manufacturing planning and control, and business functions of the firm. So if we take a look at the scope of computer integrated manufacturing itself, it covers the use of computer system to design the products, plan the production, control the operations, and perform the various information processing functions needed in the manufacturing firm. Now, the CIM or computer integrated manufacturing has an overall concept of automating things. Inside it is what we call a CAD&CAM, which covers 3 of the 4 functions in a production system. As we can see, it covers the design, manufacturing planning, and manufacturing control. So CAD itself, or computer aided design, denotes the use of computer system to support the product design function, and computer-aided manufacturing is the use of computer system to perform functions related to manufacturing engineering, such as process planning and numerical control part programming. So some computer systems perform both CAD and CAM. So the term CAD/CAM is used to indicate the integration of the two into one system. So computer integrated manufacturing involves information processing activities that provide data and knowledge required to successfully produce a product. So earlier we talked about business functions, product design, manufacturing planning, and manufacturing control. So these 4 functions form a cycle of events that must accompany the physical production activities but do not directly touch the product. So if we talk about computer-aided manufacturing itself, it is most closely associated with functions in manufacturing engineering. Things like manufacturing planning, in which computer-aided manufacturing is used to indirectly support the production function. The computer is typically used offline to provide information for the effective planning and management of the production activities. And the computer-aided manufacturing also is associated with manufacturing control. So it is concerned with developing computer system to implement the manufacturing control function, which manages and controls the physical operations in the factory. Functions of computer-aided manufacturing in manufacturing planning can be seen in this diagram, in which typically we have what we call a computer-aided process planning, or CAPP, which is concerned with the preparation of route sheets that list the sequence of operations and work centers required to produce a product and its component. So the CAPP or CAP systems are available today to prepare these route sheets. We also have computer-assisted and C part programming, which is for if we have a complex part geometries, the computer-assisted part programming represents a much more efficient method of generating the control instructions for the machine tool than manual part programming. The importance of CAM also in terms of computerized machinability data system, in which the computer programs have been written to recommend the appropriate cutting conditions to use for different material. This is especially important when we are operating a metal cutting machine tool, in which the speeds and feeds should be determined for the machine for a given work part. So calculations are based on data that have been obtained either in the factory or laboratory that relate tool life into cutting conditions. The important applications of CAM is also can be denoted in computerized work standards. So for example, the time study department has the responsibility for setting time standards on direct labor jobs performed in the factory. The computer programs use standard time data that have been developed for basic work elements that comprise any manual task. Then the program sums the times for the individual elements required to perform a new job in order to calculate the standard time for the job. And we also have CAM in estimations of cost, in which the computer is programmed to apply the appropriate labor and overhead rates to the sequence of planned operations for the components of a new product. So the program then adds up the individual component cost from the engineering bill of materials to determine the overall product cost. We also have CAM in production and inventory planning, so in which the computer is used for maintenance of inventory records, automatic reordering of stock items when it is depleted, production scheduling, and maintaining current priorities for different production orders. We also have computers involved in material requirements planning and capacity planning. It is also important for line balancing. Okay, so that means finding the best allocation of work elements among stations in an assembly line. So it is a very difficult problem if the line is of significant size. So computer programs have been developed to assist in that solution. Okay, the second category of computer-aided manufacturing is what we call manufacturing control, or CAD. So basically, the control areas or management areas includes process monitoring and control. So of course, it is concerned with observing and regulating the production equipment and manufacturing processes in the plant. The applications of computer process control is ubiquitous in automated production systems today. So that includes transfer lines, assembly systems, robotics, material handling, and flexible manufacturing systems. CAM is also involved in quality control, so in which we want to ensure highest possible quality levels in manufactured product. In shop floor control, in which production management techniques are in place to collect the data from factory operations, and the data itself is used to help control productions and inventory in the factory. We also use CAM for inventory control. Of course, we are talking to maintain the most appropriate levels of inventory, to make sure that we have a balance between minimizing the investment and storage costs of holding inventory and maximizing service to customers. And the other things that we will not cover in this lecture is we call just-in-time production system. So just-in-time refers to a production system that is organized to deliver exactly the right number of each component to downstream workstations in the manufacturing sequence just at the time when the component is needed. So this is basically the pillar of a lean production, and this term is usually used not only for production operations but also to supply delivery operations, and also in terms of inventory planning,